Hi, we have the AP Physics 1 past paper 2015. We are discussing free response question section. Question 1 is carrying 7 points. So we have the two blocks connected by the string of the negligible mass as shown in a figure passes over the massless pulleys that turns the negligible friction. Mass of M2 block is greater than M1. M2 is looking greater than M1 and both blocks release from the rest position. Question has the part A. The dots below the represent two blocks. Draw free body diagram showing the labeling force, not components, exerted on each block. Draw the relative length of vector, reflect the relative magnitude of all the forces. Okay, we have the two dots that's the representing the block 1 and block 2. We have to represent the forces acting on these two blocks and the vector representing the forces according to the magnitudes. Okay, now we consider M1 is equal greater than M2. The weight of the M2 is greater than M1. We have the larger vector for M2G and the smaller vector for M1G. And the tension on both blocks are the same because both are moving with the same magnitude of acceleration. But the one acceleration is the block 1 is moving upward and the block 2 has the moving downward. So acceleration is upward, acceleration is downward. Both are in opposite direction, but the magnitude of the acceleration is same because the tension is same. So vector of tension is have equal magnitude in these both cases. According to the figure, we can see the tension is greater than M1G because it has a greater length of vector, and tension is less than M2G. So M2G is greater than T. That's the situation we can solve for the 2 points. B part, drive the magnitude of acceleration of block 2. Express your answer in M1, M2 and G pattern. We have considered in part 1 that both blocks move with the same magnitude of acceleration. So magnitude of acceleration is same for each mass, but they are in opposite direction. If we consider the equation of motion, from here we can consider the net force is equal to T minus M1G. Because T is greater, we have the T is with positive sign and the minus mg is smaller. The net resulted is difference of these two, that is equal to m1a. Similarly, for m2g, we consider the greater difference of the two forces, that is m2g minus t, because m2g is greater. For net force is equal to m2a, because difference of these two. From these two equations, we add both equation. Left hand side is going to add left hand side, right hand side to right hand side. As an identical factor cancel out with opposite sign, we can take g common from left hand side, a common from right hand side, and we can get a is equal to m2 minus m1 divided by m1 plus m2 into g. We can arrange this tool as such: f net over m total. The denominator is the total mass, and in numerator we have m1 minus m2 into g, that is represent the net force acting on a system. Okay, so this is the acceleration magnitude we are discussing, not the direction. That's the solution of the part B. In part C, the question is the block 3 of the mass is added to the system. As shown in a figure, that's the line on the table. There is no friction between the block and the table. Part C asking the magnitude of acceleration of block 2 is now larger, smaller or the same as the original case, previous case. So we consider the block of mass 2 is now smaller because mass 2 is the pulling force. Initially that is pulling the M1 upward. Now it has to pull M3 also. So the pulling shift from M1 to M1 plus M3. So forces remain same, pulling force is same, but the mass is increased. As the resultant acceleration of the system decrease, we say the system accelerates more slowly. In mathematical point of view, the denominator total mass of the system increase, but the net force is equivalent to remain same, m2 minus m1. So the new mass is less than the previous original mass. Okay, that's the solution. If you have any query, kindly ask in the comments. Okay, take care.